Hello, and welcome to the setup and configuration of the AT-PRO5-MX810 and the two receivers. The AT-PRO5-101 SCRX scaling receiver and the AT-PRO5-101RX. The MX810 is set to DHCP by default and will receive an IP address from a DHCP server. If no DHCP server is detected, the Pro5-MX810 will automatically assign itself in this range, and you can use a network scanner to locate the device. Here in training, we encourage you to always carry a small DHCP router in your tech bag so that you can locate the devices and set the IP address to static based on the IT department for the location. When you locate the IP address, you can access the web server for the MX810. The receivers may be connected to the Pro5 matrix switcher through RJ45 or SFP+. The factory default is auto, which automatically sets the receiver based on signal detection over copper or fiber. However, you can use the dip switches on the front panel to set the unit for only RJ45 or SFP+. For more information, please consult the installation guide for the Pro5 receivers. Please note that if the dip switches are set incorrectly, the receivers will not appear in the Pro5 web GUI. Please verify correct dip switch settings before reaching out to Atlona support. The default password is Atlona with a capital A. The first time you log in, you'll be asked to change this password. This first tab is the General Information page. It gives you the serial number, firmware, IP address, as well as the time of the system. We will show how to adjust this time setting on a later tab. The next section allows you to set the password for the admin user. You can enable SSH Telnet to use this password, and you can enable or disable the TCP proxy for control. Finally, the operations section allows you to enable or disable the system standby, which reduces the power consumption on the switcher or the extension when it's enabled. You can even adjust which receiver should use the system standby as well. This is under the Maintenance tab, and we will go over that when we get to that tab. If you want to reset the system to factory setting, you can select it here, as well as force a reboot from the web interface. The second tab along the top is the network settings. Here you can change the device from DHCP to static, and we tell you the MAC address right here, so it's easy to locate and assign. The host name by default includes the last 3 octets of the MAC address. You can adjust this to make it easier to locate on the network. 802.1x is a server-based port authentication, which restricts unauthorized clients from connecting to a local area network. If an 802.1x enabled MX810 is connected to a network without an active authentication server, then the matrix will not function correctly until the expected message is returned from the server. If it is unclear as to whether the network uses 802.1x authentication, consult the IT administrator for assistance. Once the 802.1x authentication is enabled, you can choose the authentication method drop-down list and select the desired method. Once selected, the required fields for that method will be displayed. The third tab for the system is the time. The Pro5-MX810 uses an internal clock to store the current date and time. When setting the time and date, universal coordinated time must be used. Training is in Texas, so we are going to select the central time zone, and because our system is not on the network, we can manually set the time. If the MX810 was connected to the internet, we could use the NTP server. The next section is the matrix, but to make it easier to set up when you have named and set up your inputs and outputs, we are going to jump to the third tab, Configuration. Here's a diagram of our system. You can see we have a video wall that is a 2x2, a confidence monitor, and a rack that contains our sources. This could be a rack behind a lectern in an auditorium, or even a bar that uses the monitor to know what is shown on the main video wall behind the bar. Back in the configuration section, let's look at the inputs, the sources that we can use in our system. This section covers modification of input-output names, EDID management, and HDCP capabilities for each input, while also displaying video and audio information for each input. We have 6 inputs connected. You can see the green dot in the upper right corner means it's connected. The red dot means the source is not connected. Let's look at the inputs, the sources that we can use in our system. We are going to name our inputs. Input 1 is a digital signage player. Input 2, 3, and 4 are set-top boxes or media players. Input 5 is a Windows computer, and input 6 is a camera. Make sure to select Save to make the changes to the input. With the source connected, you can adjust the EDID. This data specifies the video and audio formats the display supports. The MX810 includes several pre-programmed EDID options and also allows the storage of custom EDID data. We will review the EDID management section to show how to set a custom EDID in a moment. If the input is HDCP encrypted and is being sent to a non-compliant display, the display will show a green splash screen as a visual confirmation that protected content is being blocked from transmitting. We have a number of outputs. Our first 4 are all the AT-PRO5-101 SCRX receivers. These are the scaling receivers, and they are connected with SDVoE and will be part of our video wall. So in order to know which output is which location, we are going to name them so that I know they are SDVoE and which location in our video wall. Output 1 is SDVUL for upper left. Output 2 is SDVUR for upper right. And because the video wall will be a 2x2, we will name output 3 SDVLL for the lower left and output 4 as SDVLR lower right. Notice after each change of the name, you must select the Save button. Our output 5 is set up as a fiber extender, and we did not require scaling, so it's the Pro5-101RX. We are going to name it Fiber Lobby, so we can tell how it's connected and where it's located. Finally, we have 2 additional outputs that are HDMI, and we have a confidence monitor near the Pro5. So if I need to check the status on an input, I can simply select output 9. Now the first 4 outputs are connected to the Pro5-101 SCRX scaling receivers. You can choose to change the display from Genlock to Scaler. Genlock is the default video mode for the scaling receiver and is also the video mode for the 101RX standard receiver. This allows direct video pass-through with no video processing, such as scaling. Genlock mode is required for passing HDR video. It also is ideal when displays need to be in absolute sync. When selecting scaling, you will find 2 additional modes, Fast Switch and Genlock Scaler. Fast Switch applies scaling at a selected resolution and frame rate optimized for the display and enables quick switching between sources. Because of the video processing, this mode introduces 1 to 2 frames of latency. Genlock Scaler applies scaling at a selected resolution while maintaining the timing of the source signal. Source switching is slower than fast switch, but this mode allows precise sync between displays without video processing latency. It is important to note that in either scaling mode, HDR signals will be converted to standard dynamic range. For passing through HDR video, you must use Genlock mode. Before a source can send picture and sound to a display device, the source reads the EDID stored in the display. The EDID contains information about what type of video and audio formats are supported by the display. The Pro5-MX810 can use a factory-programmed EDID. the downstream EDID from the display, or a custom EDID. The switcher provides 5 blank memory locations that can be used to store EDID data. By default, the MX810 will use the ATL 4K60 MCH HDR EDID for each input. You can assign the different EDIDs, the inputs 1 through 4, all work with the default EDID. Finally, let's look at how we could create a custom EDID. We are going to select one of the video wall outputs, copy the EDID, and then select another video wall output and paste it over the placeholder. We are going to name this EDID Video Wall Displays. Make sure to save. Back on the input for the camera. Let's change the EDID to the custom EDID we just created. One of the features of the Pro5 series matrix switcher and receivers is that there is no web server on the receivers. You can see under this configuration tab, you can set up the analog audio name. When we set up the names of the inputs and outputs, these names flow through the configuration pages. Let's name our matrix local analog, which is connected to our amplifier. Line 1 is connected to amp channel 1, line 2 to channel 2 through to output 4. On the receiver side, I'm going to name the receiver based on the location. Remember, there is no web server for the receivers, so this is where you would set the name, change the volume, mute, and see what audio source is currently selected for this receiver. Now you might be wondering about the sources. Let's go back to the Matrix Switching tab and look at how we can set up our Matrix Switcher. The AV routing page manages the assignment of input video sources to outputs. By default, the PRO5-MX810 is configured for one-to-one routing, where input 1 is assigned to output 1, input 2 to output 2, and so forth. Additionally, input 1 is routed to output 9, and input 2 is routed to output 10. To route a single input to all outputs, click the All checkbox. In this example, input 2 is routed to all outputs. If the AV routing is grayed out, it will tell you that it is being used by the video wall. But if you come into an existing system and see this, you will understand there is a video wall enabled. By default, the audio follows video. The analog audio routing page controls the distribution of de-embedded input audio to analog audio outputs. When the follow video setting is turned off, you can manually route the audio to whatever analog audio port on the switcher you want. However, there is still audio being sent to the receiver for which you have routed video. Or put more simply, these controls are only for controlling the routing of analog audio from sources in the switcher to the analog audio ports on the switcher. And this is not controlling the routing of audio to the receiver units. The presets page allows saving and loading of input-output switch configurations to and from the matrix. Up to 10 switching presets can be stored. Let's say we want input 1, which is digital signage, to go to all the displays. Let's change the preset name and hit save. Now, on the AV routing page, we will select the routing, and back on the preset page, we will save the routing. Now, you see the activate button is orange. Next, I want to send input 5 out 1 through 4 and input 6 to output 5 and 9. Select save, and then change the preset name to computer and select save. Now let's activate the digital signage preset and check the routing. Let's go back to the computer preset. These presets can be activated through a control system such as velocity. If you want to use a video wall, scaling receivers are required. They may be used with RJ45 or fiber, but remember it is one or the other on a single extender. Let's look at our design again. This video wall takes 4 separate inputs when video wall is disabled, but when it is enabled, the source will span the entire video wall configuration. The video wall configurations are 2x2, 1x3, or 2x4. Our video wall design is a 2x2. Under the video wall output section, click the radio button that corresponds with the desired output. In this example, output 1 has been assigned to the top left window, output 2 to the top right window, and so on. Now it might be that my video wall scaling extenders were connected to outputs 5 through 8. We do not force the location of the video wall extenders. However, if you choose a 2x4 but want it to look like two 2x2 video walls side by side, this feature is not available at this time. It would need to be a single source across all 8 displays. You can choose between any of the sources to be used on your video wall. The computer would be the entire video wall. Same with our digital signage or any of our set-top boxes. On each display, make sure the image is aligned correctly with the other images on the video wall. Adjust the fields under the bezel adjustment section to adjust bezel compensation if necessary. To do this, you will want to get the width and height of the outside of your displays and the interior width and height. These dimensions should be converted to millimeters. This is our demo video wall without bezel adjustment. You can see the computer doesn't look right. Let's add the correct adjustments in millimeters. Now you can see the change even on our demo video wall. Click the resolution drop-down list located under the video wall resolution section and select the desired resolution for an individual display in the video wall. In most cases, the default 3840 by 2160 is sufficient. For the video wall modes, the adaptive wall is the default. In this mode, the receivers are timed to the source signal. This ensures all screens are synchronized for the best performance with no image tearing. For fast switch wall, video wall processing is applied to allow quicker source switching than adaptive wall mode. Due to video processing latency, the trade-off is a slight timing variation of 1 to 2 frames between displays. Just like the Matrix presets, you can set up your different video wall configurations and save them to be activated by a control system. Once it's saved, the Activate button will show up. If you'd like to set a preset name, you will need to select this Save button separately. Remember that only the scaling receiver, the AT-PRO5-101 SCRX, may be used on the video wall configurations. The Control tab is for the extenders. You can set the RS-232 baud rate for each of the ports, and it will automatically save. For our system, I have set up the RS-232 to an LG display using the extender output 5. I am going to change the baud rate to 9600, and I'm going to look up some simple commands: on, off, HDMI 1, and HDMI 2. In many cases, you can see the device and know that the code works, but sometimes the programmer needs to test strings and can't see the device. So to watch this port, I will open up PuTTY and use a Telnet proxy, basically sending the serial protocol through the IP of the Matrix switcher, and use the proxy port 9005. This is the port for the 5th extender that I have physically wired via RS-232 to the display. Now I will send the code for HDMI 1, and you see I get the acknowledgement. Let's switch it back to HDMI 2. I know my wiring for the RS-232 control is correct. On the CEC tab, we allow you to change the on-off CEC codes, and it will save them to be used with each extender. Because the entire ecosystem is standalone, please make certain your extenders are connected when updating the firmware. The package will update the MX810, as well as any Pro5-101 SCRX or the Pro5-101 RX extension devices. Here is where you can download the log for use by our tech support teams. And this is where you can test the API commands for the MX810 switcher for your control system. This is the page we mentioned earlier under the System page. To conserve power, the Pro5-MX810 provides the ability to disable the PoE function for ports on the extenders when they are not in use. We created the Pro5 to be used with a control system. Our Velocity control system allows you to make all of these settings and presets directly from the Velocity device manager. You can also create macros that will enable and disable the video wall so that you can change your preset configurations with one button press. Thank you for watching the setup and configuration video series for the AT-PRO5-MX810 and the receivers. For more information on the Pro 5 series, you can go to atlona.com.